Today we're talking about the string and the bow. This is sort of a complicated video, so make sure you stick with me. I've brought some graphs to help explain everything. So the first part of the string moving with the bow is that it's going to be very similar to the Helmholtz corner that we discussed in the pizzicato video. The difference is that, of course, the bow replenishes that corner constantly, so the sound is going to continue, the overtones are going to continue, unlike pizzicato where they die out very quickly. The string moves with two phases under the bow. The first one is sticking friction, and the second one is slipping friction. Let's take a look at those two phases. So you can see in sticking friction, the string moves sideways at the speed of the bow because the bow has picked up the string and it goes with the bow. But at some point, the tension on the string and the friction on the bow become too great and the bow releases the string and the string snaps back to the other side. That snapback is called slipping friction. And you can see it on the right side of this chart. You can see the corner is let go of by the bow and it zooms around the string, reflects from the end and comes back to the other side, where once again the bow picks up the string and the sticking phase starts again. Sticking, slipping. This process happens 440 times a second on the A string, 660 on the E string. You get the idea. It happens very, very, very fast. And the only part of this process that the violinist gets to decide is, of course, the sticking phase, because that's when the string goes at the speed of the bow. The slipping phase is determined by how fast the string has to move. So let's go to this graph. This graph shows us what happens if our speed is not fast enough. On the left side, you have a constant weight, a constant location, and a constant corner or amplitude as well. And you have a slow speed of the bow. In this case, the bow speed is so slow that it takes the entire time period for the violinist to pull the string to the side. And then there's no time left for the slipping phase. So when the slipping phase happens, it's going to add another tiny bit of time to the period, and that means the pitch lowers. You definitely don't want that. That's what happens when you get crunching noises or even a little bit in subharmonics, and when you get this kind of lowered, flattened pitch from either too much weight or too little speed. On the right side, you have the correct amount of speed, where you have a faster speed of the bow. So of course the faster speed pulls the string to the side faster, and then it has time to achieve the slipping phase. So 0.9 seconds to the side, 0.1 second on the slipping phase. Now we have periodic motion and the correct pitch. So this just gives you an idea of how this works. The couple of things to remember are that the motion that you see occurs in the horizontal plane. And that means something very, very simple. There's a very small number of differing weights that you can use for the violin. Now you do have to have a minimum weight, but the minimum weight and the maximum weight are very, very close together. On the contrary though, the number of speeds you can use, quite a great number of different speeds. And that means that speed is probably the more important focus for the violinist once weight has been trained. So as you experiment with this, you can play around and see what happens, but really be aware of whether you are dropping in too much weight into your string. More often than not, the professionals that I hear play are putting in either too much weight or not enough speed. If you look at the Berlin Philharmonic, they're a great example of putting in enough speed and wonderful, wonderful sound quality as a result.